Hello everyone! Today I'm super excited to announce that our new Viscometer is here. Now it's time to say goodbye to our beloved m-VROC 1 and replace it with the next generation m-VROC 2 with many upgraded features and advanced software functionality to further simplify viscosity testing. Before I show you how fast and easy you can measure your sample with this product, I would like to share why we are so passionate about this product by highlighting some of its more important features. Number one, the minimum sample volume has been significantly reduced to 15 microliter, so it would be beneficial for testing costly or limited quantity formulations. Number two, reservoir has been introduced for sample retrieval and recovery, so sample can be retrieved back into the test syringe during the measurement, so multiple measurements can be done with single loaded sample volume. That this feature allows you to maximize the data with only 15 microliter. Number three, you can access higher shear rates with m-VROC 2, potentially up to 2 million inverse second, which is the highest among all the real-sense viscometers. Number four, m-VROC 2 comes with an advanced software that allows users to measure their unknown samples. So you do not have to guess the viscosity of your sample because the software is intelligent enough and it can take care of your sample by using advanced automatic measurement protocols. Number five, in m-VROC 1, water bath is used to control the temperature, but now water bath is gone and m-VROC 2 uses a Peltier temperature control to control the temperature in the range of 4 to 70 degrees Celsius. Number six, m-VROC 2 comes with a chip cleaning station, so you shouldn't be worried about cleaning your chip because the chip cleaning station is designed to do the dirty work and clean the chip efficiently for you by using the preloaded cleaning protocols. Alright, after this quick overview of the highlighted features of m-VROC 2, now I'm going to show you how you can measure your sample. Before I start measuring my sample, I would like to introduce you the main components that we use for each measurement. First one is called reservoir. As I mentioned earlier, reservoir is used for sample retrieval and recovery. The second component is chip, m-VROC chip, which is the core of m-VROC technology. The microfluidic channel and the pressure sensors are located inside the chip. And the third component is syringe, test syringe. There are two syringe configurations, 2.5 milliliter syringe that is typically used for higher shear rates measurements, and 100 microliter syringe that is typically used for low sample volume measurements. Okay, today I'm going to show you how you can measure the viscosity of your sample with 15 microliter sample volume. So for loading the sample, I use positive displacement pipette and I set the volume at 15. I want to measure IPA. I slowly load the sample into the pipe. Sample loading is critical because we have to be careful to do not introduce bubbles into the sample since the presence of bubbles can significantly impact your measurements. Because this tip is perfectly fits in the back of the syringe, I hold the syringe horizontally and then I slowly load the sample into the syringe. we push the plunger all the way to the mark of, here you see the mark of 40 microliter. So for low sample volume loading, we do not push the plunger all the way to the tip of the syringe. After you load your sample, you can easily connect these components together. Here is your setup. After this, you can connect the reservoir outlet tube to the reservoir and mount the whole system on the cold plate. So after this, I close the cover, and then now I'm going to show you how we use sulfur to measure the viscosity. Alright, so I loaded 15 microliter of sample, and now everything is ready for an accurate measurement. So let me show you a little bit behind the scenes. I mean the m-VROC to sulfur, so you will see how much effort our team put into this work to develop this user-friendly software. The m-VROC 2 advanced software with upgraded features has been designed to better assist in high accuracy viscosity measurements. For example, it helps to automate measurements, simplify protocols creation, and to organize and analyze your data. For this video, however, I'm not gonna show you all the details and specifics of the software. I'm just gonna show you how easy you can measure viscosity with just a click of a button. For that, I go to Experiment tab, Design sub tab, and the GUI that you see here displays graphical icons like syringe bar display that shows real-time sample volume, and the progress bar in the right that shows the status and the duration of the measurement. So you can write your sample name in the sample name box and then select the proper measurement protocol from this drop-down menu. Also on the top of the software, here on the GUI, you can see the serial number of the chip, and also it shows that the chip is dry and clean and it's ready for your measurement. So for today's test, I would like to use automatic measurement protocol in which the software controls the shear rate to measure viscosity at 25% of the full scale pressure of the chip. This is one example of a preloaded measurement protocol that allows you to measure your unknown sample. As you see, this measurement protocol has two steps. First step is priming, a segment which is used to prime or wet the chip. And the second step is the actual measurement with 5 repeats. Well, I think everything is set, and now I can click on a start button. For this test, I'm gonna turn off temperature control in order to have a time-saving experiment. Okay, now this instruction pops up that says please close the latch and click OK. Okay, once I click on start run, and before running the job, it will perform diagnostics including chip test and leak test. Alright, so no issues found and the diagnostic passed. Now the measurement will begin. So you always can check measurement results. Here, for example, there are 4 graphs. Now it's during the priming step. This graph, the first graph, shows viscosity versus time or transient curve. The second graph is showing temperature. Third graph is showing pressure versus sensor position. That shows the pressure drop in the chip during the test. As the fluid travels through the microfluidic channel, it experiences a pressure drop. And the last graph is showing the viscosity data versus segment number. You also can see the actual loaded volume, which is 14.7. So when I set the positive pipette at 15, so I could transfer 14.7 into the test syringe. After the priming step, it retrieved the sample for the measurement. So yeah, here is the transient curve. This is an example of an acceptable transient curve. There is an increase and then followed by a plateau. Okay, meantime that this job is running, I would like to show you the chip cleaning station. Well, okay, meantime that our measurement is running, I would like to clean another set of reservoir and chip. So this is the cool option that CCS provides for us. So while you are running your measurement, you can clean another set of reservoir and chip. There are two cleaning modes. The first mode is called host mode. So after the measurement, you can take out chip and reservoir, remove the syringe, and then mount the chip and reservoir on the CCS. Then you can select one of the preloaded cleaning protocol and just click on start, and then the CCS will do all the work for you. Alright, so let's go back and take a look at our data. Well, the measurement is done, and this progress bar showed that the measurement is complete, and here is the data. On this graph, we can see the viscosity of IPA for 5 repeats. I think this is very good data. We could collect reliable and accurate data for IPA. Then you can export your data using one of these options. You can see on the top right of the screen. So you can export your data as Excel file or CSV or database, and then you can analyze your data. I think that's all for today and for this video. If you have any questions regarding m-VROC 2 or any other technical questions about the compatibility of your sample with our viscometers, you can contact us at RiaSense. We are here to assist you with your rheology and viscosity questions. Thank you.